Hello, this is Cody Hosterman, and I'll be showing you a demonstration of semi-transparent failover in a VMware environment on the Pure Storage FlashArray. Right on the screen here, you can see my VMware environment, and I have two virtual machines. So they're both running Windows 2012. So take a look here. They're booted up, looking good. Take a look at the other one. Open the console. All right, they're both up and running. So the first virtual machine here is running on my ESX3 server. Since its name, it's not the version, and then ESX4. This is all running 6.0 update 1 if you're curious. The first virtual machine is on its own data store, FlashArray VMFS 01. We'll take a look at using the Pure Storage web client plugin to see, yes, it's running on my 405, and this has the same name on the underlying volume as the VMFS. Take a look at the other VM. It's on this data store, 02, and it's on the same FlashArray with the same name as the VMFS, FlashArray VMFS 02. So we have two VMs, two data stores, two hosts. So if we take a look at the protection scheme here, we can see that my FlashArray volume is inside of one of our protection groups, which is a consistency group for either local snapshots or remote replication. You can see my volumes also have some FlashArray local snapshots on that array that can be used for replication or local recovery. Alright, so let's take a look at our storage infrastructure on the FlashArray. So I have a host group on my 405, so this is what those VMs are currently running on. I have two hosts for my ESX servers and my two volumes connected to that host group. If we look at our protection tab and take a look at our protection group in more detail, we can see the replication schedule. It replicates every once an hour, obviously not very aggressive. We have one target, FlashArray, my 420, and we have the two volumes included inside of here. So let's look at my target FlashArray as well. So we go over to my 420. You can see, yes, this is indeed my 420 FlashArray. And we have the same host group configured with my two hosts, but we don't have any volumes connected onto it because everything's running on my other array. So let's look at our protection tab, and let's look at the target view of that protection group. So we look at my target groups, see my 405 expanded, and we see my one protection group. We see that our source FlashArray volumes are in there. And let's look at our snapshots tab. We see a bunch of snapshot point in times. If we look at the top one, which is the latest one chronologically, we can see we have my two snapshots inside of that. That can be copied and used for whatever, right, to recover from and so forth. But we'll do that in the script that I show you shortly. So the next step would be to simulate a failure of the storage. So what we're going to do is we're going to rip out those volumes on the FlashArray non-gracefully, meaning we're not unmounting and detaching. We're just ripping them out on the array and disconnecting them from my host group. So the volumes are now disconnected. And let's jump back into the web client. Let's give a refresh of the storage subsystem to see those volumes have gone away. It would automatically happen anyways, but we'll kick it a little bit quicker here. And we'll see that my volume, if you look at the data store under that, is now inaccessible because it's gone. And if you also look at the virtual machines, you see they're tagged with a question object. That question is about, hey, we've lost the storage, what do you want to do? But we'll leave that alone because we're going to actually have the script handle these questions. So let's start the script. Alright, so the script is written using PowerShell and of course VMware's module for that, PowerCLI. This allows snapshot LUN failover. So we're going to enter in the source name of our FlashArray. This helps us identify the right snapshots. Now we're also going to enter in the IP or FQDN of our target FlashArray, the one we're failing over to. This allows us to make access calls over our REST API to control that array. We'll give it credentials for our target FlashArray, enter in our vCenter information, so our FQDN or IP to connect to, and of course its respective credentials as well. Now the last part here is a CSV file. So if we take a look at my CSV file, it has a couple things. It's a listing of my volumes that I'm failing over. It has a list of target volume names that I'd like to use. And it also has a listing of the cluster that I want that volume to be presented to. Right, so this allows you to list a lot of volumes in the same script to fail over, and also have disparate clusters if you have different clusters for different volumes or different VMs and all that kind of stuff. So you put that in that CSV file. Now we'll pass the path of that CSV file into the script and give it a start. So we'll verify the information, it's all correct. So we'll type yes and move forward. So it's going to connect to the FlashArray, going to connect to the vCenter, and now it's going to start gathering some information. So the first thing it's going to do is going to kill those virtual machines. It's going to power them off and answer those questions. Because if they're still running when the new volume gets presented, they won't actually see the new storage. So they need to still be powered off, but still registered. So at this point, we're going to figure out the worldwide names. We're going to match everything. And then we're going to go to those ESX servers, and we're going to actually turn on, or turn off rather, disallow snapshot LUN. This allows volumes to be automatically force mounted when ESX rescans the SCSI system and sees unresolved volumes. So it'll go ahead and automatically mount those volumes. So you can see that my VMs are now back. They're no longer inaccessible. And my VMFS volumes are also back. But if we look at the underlying information for that VMFS volume, it's now changed. That volume is now actually sitting on my 420, not my 405. So we've recovered that VMFS without unregistering the VMs or unmounting that volume, anything like that, on a different FlashArray. So the next step what the script is going to do is going to start powering on those virtual machines. So the virtual machines are powering on, and the OSs will start booting up. So if we refresh the screen, we can see that these VMs are now powered on, and if we open up their consoles, we can see, yeah, they've already booted up into the Windows OS. So now these VMs are running on force-mounted data stores, which generally I don't advise doing, right? Because situations can cause those data stores to go away. If someone accidentally resignatures, things like that. So what we're going to do next is when we created those new volumes as recovery volumes, we also created respective final volumes for these VMs to sit on. So the script is now going to take all those VMs on each data store and storage vMotion them to new data stores that are the same size and similar configuration of the original volume. So those VMs will now be moved over to properly configured and signatured VMFS volumes that are much safer than force-mounted ones. And then we'll actually go ahead and delete and unmount and detach and then disconnect and delete the original volumes that are no longer needed. You'll note that we also rename the data stores, so the final data stores that we'll have sitting there will actually be the same name, VMFS name, and also the same underlying FlashArray volume name as those original volumes that we failed over from. So we'll move those VMs over, we'll rename them, or rename the data store rather, and then we'll get rid of the old one. So by the end of this script, your environment will be identical to the way it was before, with the exception that these VMs are now running on my target array instead of my source. So the important thing to note about this script is that the main purpose of it is to get those VMs up and running, powered on, as quickly as possible. Everything else is done, for the most part, after those VMs have been powered on. So really the goal is to decrease the RTO to get those VMs powered on, and then we'll take care of everything in the background after those VMs have been turned on. And the way the storage vMotion works on the FlashArray is we're just moving metadata pointers. And so moving these VMs is not increasing data usage, and it's also very quick to do because we're just moving metadata. We're not moving or copying data on the FlashArray because that would be wasteful. Just metadata relocation from one volume to another. Once the volume deletion, unmounting, storage vMotion, all that kind of stuff is done, then we'll go and turn off that value we set, that disallow snapshot LUN value, and now we're going to re-enable it so volumes won't automatically be force mounted unless you want to actually do that on a one-off basis. Right. Now the value has been reset and the script has completed and all the sessions have been disconnected. This has been a demonstration of semi-transparent failover in a VMware environment on the Pure Storage FlashArray. Thank you.